Punctuated equilibria is of course a theory about how the evolution of species occurs over long time scales and contains both punctuations and equilibria, the juxtaposition between periods of relatively rapid change with periods of little or no change. The latter intervals are referred to as times of stasis, and stasis is undoubtedly one of the key contributions of punctuated equilibrium to evolutionary biology. Indeed, the idea of stasis was baffling to many evolutionary biologists because first, they had been taught to assume that change was omnipresent. Second, because they could observe that populations of species show substantial amounts of change over ecological timescales. How can that square with a fossil record showing overwhelming evidence of stasis in species? When thinking about what might cause stasis, a mechanism of stasis that is widely discussed is the geographic organization of species. Many species are broken up into different groups, called populations, or demes, that occupy different geographic regions. Further, in each of these regions, the abiotic and biotic environments, and thus the selection pressures the population experience, are unlikely to be the same. Because of this, each of these populations may have its own quasi-independent and partly distinct evolutionary history. Each population may undergo its own changes, adapting to different environmental parameters or diverging at random, but the total change within the species represents the net sum of changes across all of the populations. These will tend to cancel out, yielding little change. In addition, if the populations are still able to interbreed and exchange genes, whatever changes that have occurred will be homogenized, again resulting in stasis. Indeed, it is this geographic structure of species, and the fact that they are hierarchically organized and consist of populations, that appears to be one of the key factors maintaining stasis. Ultimately, the examination of mechanisms of stasis is one of the many areas where paleontologists and neontologists can work together to increase our understanding of evolutionary theory.